Welcome to the course Digital Transformation and Technological Innovation. We are into our fourth module, that is Tech Advancement and Internet Basics. So, let us continue our discussion from where we left in the last session. So, we were talking about the IP address scheme, right, and we talked about IPv4. So, we said that IPv4 is the original scheme that still remains a widely used format, and how it is expressed? It is expressed using a group of 4 numbers, where each number will have each one will have 1 byte. So, 1 byte per number, right. So, total 32 bits would be there, right, and these 4 numbers would be separated by dots. One example is here, you can see these are the 4 numbers separated by dots, right, and 1 byte per group. So, therefore, there are 4 bytes, and therefore, there are total 32 bits, and so the range of each number, because there is 1 byte for each number. So, to the power 8, that is 0 to 255. So, essentially this is how the addressing happens. If we look at the total number of possible addresses, IPv4 addresses, that would be to the power 32, and which comes out to be approximately 4.3 billion IPv4 addresses, right. So, these IPv4 addresses are actually given to the computational node, and they work like a unique numerical identifier for the computational node in internet. And you can understand the scheme. While this number 4.3 billion, this will sound like a lot. So, when this scheme IPv4 was originally conceived, this number looked quite quite big, but over a period of time there are so many computing devices that are now connected to the internet. Because of that, we are running out of IPv4 addresses. So, therefore, ability to uniquely identify a computational node is going down, and there are different solutions that are adopted to overcome this lack of IPv4 addresses, right. Now, so essentially we are facing IPv4 address exhaustion problem. So, why that has happened? As I said, explosion in the number of devices connecting to the internet, right. So, all of us at individual level, we have so many devices, starting from a desktop, laptop to smartphone. We might also have a tablet, then we might have a speaker at home, and therefore, per person there are so many devices nowadays, right. So, smartphones, tablet, speakers. So, these are the new additions in the set of computational devices that are connected to the internet, and there are more now. So many appliances and other products, they are also getting connected to the internet. We talked about many such examples while our discussion on fast cheap computing, right. So, because of that, all these computational node, different kind of devices, they would need IPv4 addresses for their connectivity to internet. So, there is an IPv4 address exhaustion, and that is a challenging problem. Now, apart from the increase in or explosion in number of devices that are actually connecting to the internet, another reason for IPv4 address exhaustion is inefficient allocation of addresses. So, initially when the IPv4 was conceived, then nobody thought that eventually they will run out of addresses, and therefore, the allocation of addresses was very inefficiently done. Certain organizations, corporation, firms, they got they were given lot more number of addresses which they were not utilizing, and other people who actually need IPv4 addresses, they could not be allocated the addresses. So, therefore, there was inefficient allocation of addresses. So, that has also created a problem, contributed to this problem of IPv4 address exhaustion. Then what is the short term solution for this? So, short term solution is something that has been going on for many years now, where what firms do, they buy IPv4 addresses from those with excess capacity, right. So, there are lots of firms with excess capacity, they are not utilizing, but they had but they were allocated IPv4 addresses initially. So, other firms which now have, which can pay such firms and they can buy IPv4 addresses, or there are firms which might have run out of business, they might be facing bankruptcy, they might be on the verge of closeout. So, what happens to their IPv4 addresses? So, obviously those can also be bought by other firms who need more IPv4 addresses. So, short term solution is this buying of IPv4 addresses from those with access allocation, right. So, another, but this is not a solution that all firms can actually go for. Then obviously we need a more technological solution there, and one short term solution that is sort of technological solution is that firms use a gateway to allow multiple devices to share a single IP addresses using NAT. So, NAT is the technique that allows firms to use a gateway and allow multiple devices behind that gateway to share a single IP addresses. So, for the outside world, for the public, for the external world, all the requests would seem to be coming from that one device, that one IP addresses, but actually there is a gateway which is using NAT and therefore is able to allow multiple devices to share that single IP address, right. So, this is the short term solution that is commonly applied, especially in the case of developing countries. So, developing countries were the ones which actually faced the IPv4 address problem, because the developed countries got the allocation extra allocation, and the gateway is something that is very commonly seen in developing countries as a short term solution, right. So, obviously when we talk about this gateway and multiple devices sharing the single IP addresses, the speed will go down. So, therefore, firms which have to do this are at a disadvantage in terms of network speed, in terms of internet speed, right. So, the short term solution is something that works, but it is not something that is very desirable, right. Now, what is NAT? So, NAT is network address translation, right. So, NAT is network address translation. So, it slows down the internet access, but then it addresses the problem of IPv4 address drought. This is complex, cumbersome and expensive also. For that, organizations, firms will have to pay extra, or spend extra rather, to manage the gateway and implement NAT, and there would be expenses for this, devices, networking, and the cost to the labor and all that. Now, NAT or network address translation, this is actually a networking method that allows multiple devices on a private local network to share a single IP address to access the internet. The same thing that we talked about. So, NAT plays that role, and as is suggested by its name, network address translation, right. Now, the NAT enabled router or firewall, they would actually act as intermediary here. So, they would be doing this translation part, right. They will enable the sharing part. So, NAT enabled router or firewall, they will act as an intermediary, and what they will do, they will rewrite the source destination IP addresses in the headers of data packets in transit. So, the data packets which are being sent from one client computer to a server which is outside the organization, right, which is outside the organization's domain network and all that. So, there would be header which will be having the source, which will be having the IP addresses, source or destination IP addresses. So, the NAT enabled router or firewall which is acting as a gateway, which is acting as a intermediary, it will actually rewrite those entries, because it is the same single public IP address that is shared. So, that rewriting of those entries will happen, and then it will be doing the translation. So, whenever a packet is coming back, then again this gateway will do the rewriting of short there, right. So, what are the benefit of NAT? So, this is a short term solution, but apart from addressing the main problem, that is IPv4 exhaustion. There are other benefits that also come, but then there are other complexities also that come, so we will talk about that. So, IP address conservation. So, in case firms are having certain IP addresses which are more than what they required required currently for their immediate business needs, and but there is no not much chance for them getting or buying new IP4 addresses. So, they need to conserve their IP addresses for future uses, right. So, if they implement NAT, this will give them some breathing space. They would be able to conserve IP addresses. So, this prevents IPv4 exhaustion at the organization or firm level, and so that is one benefit to the firms which go for NAT. Obviously, it comes at the cost of network efficiency. So, network cost efficiency. Another benefit is that reduces the need to buy unique public IP addresses. Both are connected. So, IP address conservation is happening. So, therefore, your need for buying new unique public IP addresses, that goes down, and that will cut down ISP expenses, because you are not buying more IP addresses, and therefore, it will improve the network cost efficiency, right. So, while the problem that we talked about, that this NAT solution comes with the cost of slows down the internet access, but then there are some other benefit that it provides, because you might not get new IPv4 addresses. NAT benefits that you can conserve what you have, whatever you already have, you will have better network cost efficiency. Then another benefit through this process is that now you have, because of this NAT, you have now a gateway thing between the organizations network, between the domain network and the external world, the external network, right. So, that in a way helps in managing security and privacy, because the NAT enabled router, they in a way hides internal network and private IP addresses from the public internet. So, the public internet, external entities, external users, they have no way of knowing the private IP addresses. So, that part, the internal network and the private IP addresses remain hidden, and that gives a additional layer of security, because what is what is visible to the outside network is actually the gateway, right, that single shared IP address, right. So, that in a way creates another layer of security. Now, how it creates that? External attackers, now they cannot directly target internal devices, since only the router's public IP is seen. So, that translation where translation or reaching to a particular computing device, that is not feasible, because it is not visible, right. So, this is how the attackers, the devices can in a way, because of the NAT, same mechanism which is used for to deal with the IP address exhaustion is actually can help in case of dealing with the external attackers. Now, what is the long term solution of all this, right? So, the long term solution is new IP scheme. So, this was realized many years back, that IPv4 addressing is no longer sustainable, and for number of reasons that we have already talked about. So, new IP scheme was conceived, that is IPv6. So, it increases the number of possible address space way higher than what is there in the IPv4. So, the possible address space goes up to a new theoretical limit, that is 2 to the power 128. Now, the IPv4 limit is 2 to the power 32. So, this is a very high increase in terms of number of addresses that are possible. So, address space goes up to a very high theoretical limit, that is 2 to the power 96 times more addresses than IPv4. So, and the IPv4 itself is 2 to the power 32. That means IPv6 is very huge in terms of address space in comparison to IPv4. right. So, obviously, it solves all kinds of future addressing problem in terms of number of devices and all that. So, how it is expressed? It is expressed as a group of 8 numbers, and each number will have 2 bytes, and so total there are 8 and 2 bytes. So, there will be 16 bytes, and therefore, there would be 128 bits that are there, and because of that 2 to the power 128 possible addresses are there in IPv6, and it is separated by columns. So, the IPv4 was dotted decimal notation. Now, here it is column separated hexadecimal notation. So, these numbers, each number has 4 hexadecimal digits. So, you can see each of these numbers, and each each one of these are in a way hexadecimal digit. You can notice A, E here. So, essentially from there you can understand that we are following a hexadecimal format, right. So, here you have these are all hexadecimal. So, here you have essentially these are 8 groups, these are 8 numbers 1, 2, 3, 4, 5, 6, 7, 8. Now, there is double column notation to do the compressing of IPv6 to conserve that. So, that part we are not covering, but you can see that there are 8 numbers here, and each number will have 2 bytes, that is 16 bits. So, each of these hexadecimal digit can be represented using 4 bits, right. So, therefore, you would be able to understand that 4 bits are needed for each of these 4 hexadecimal digits. For representing the one hexadecimal digit, we need 4 bits, and total 16 for 4 numbers for 4 digits in the number, and total 8 such numbers, right. So, essentially that is how the address is expressed. So, you are looking at an IPv6 address, and if you compare that with the IPv4 address. So, that was one example is this. So, this is dot separated, right, and this is decimal notation and dot separated, and when we come back here, this is column separated, and this is hexadecimal numbers are being used there. So, this is about the IPv6 new scheme that will actually address, that is actually the long term solution to actually address this IPv4 problem, right. Now, there are transition challenges from moving away from IPv4 to IPv6, because IPv6 is not backward compatible with IPv4, right. And because of this lack of compatibility, the immediate transition, the quick transition is not possible. So, it is a gradual transition that has to be done. So, that means the devices will actually have both addresses IPv4 and IPv6, and slowly the IPv4 addressing is to be phased out. So, because of that, the simultaneous uses of both the formats IPv4 and IPv6, there is a very slow transition. So, there is no immediate transition. As more and more services on internet, they become IPv6 compliant. So, therefore, it will be that can speed up this transition process, right. But still there are lots of web services over the internet which actually are IPv4, which actually provide services only through IPv4. So, because of that the slow transition is there. But whenever that happens, once IPv6 full deployment is achieved across the internet, then there are certain key benefits that are to be gained. So, if wide scale deployment of IPv6 happens, then there will be potential improvement in the speed, reliability and security of the internet. Then what will happen? Suddenly we will see the year we achieve full wide scale deployment of IPv6, suddenly the speed will internet speed will increase to multiple percentage point, right. It can increase many folds because of that. So, this improvement in internet speed is still awaited because of the slow transition, because of the lack of backward compatibility of IPv6 with the IPv4. Then Coming back to our discussion of URL, and we talked about the domain names that are there in the URL. So those domain names are human readable. So, but the computing works based on numerical format, right. So therefore we need a service. So while humans can memorize the domain names, but the machines work with the numbers. So therefore we need a translation, right. So that translation is referred as domain name system, right. So it's just like telephone directory, we remember the name and we use the telephone directory to find the telephone number. Same thing is here, we can easily remember a domain name because those are human readable text format, natural language format. But for the machine there has to be a translation of those domain names to actually numbers, right. So numerical IP addresses, so human readable domain names like google.com needs to be translated to numerical IP addresses like something like this. So who does this job? So domain name system is there that does this particular role, and it works like an internet phone book, just like telephone directory. It domain name system, right, it works like internet phone book and does the translation of domain names to numerical IP addresses, right. So why this is needed? As I said, computational nodes, they communicate strictly using numbers, and it is for the humans to actually type the domain names in the natural language format in the URL, URL bar of the browser or the client software, but actually then the translation would be needed, which is done by domain name system, translation to a numerical format. So as I said, the question that why are human readable domain names used? Because memorizing, if you were to access hundreds of websites for your work or other purposes, so memorizing those hundreds of long numerical strings would be impractical for humans. We can, just like we can memorize or we remember maybe hundreds of friends or relatives and other people. Same way we can memorize the we can easily memorize the domain names, but memorizing numerical strings corresponding to that will be impractical, right. So therefore this DNS thing is needed. So DNS runs silently in the background and it handles the conversion in fractions of seconds. It does it's a mapping. It does a very fast mapping from domain name to IP addresses. So DNS is responsible for taking care of this conversion. Now when you are you have bought a fresh computer system and then you are looking to access a particular website, you open a browser, you want to access a particular website. That first time when you are doing this, then that mapping is not there, right. So that domain name mapping in your local device, that is in your new computer system, is not there, and because the mapping is not there, how will your new computer get to know what is the IP address for the domain name that you are looking for, that URL that you are trying to access? Then DNS resolver is there in the network, and domain name system is part of the network, and that DNS resolver will actually be the first stop to facilitate this conversion, right. So typically managed by an ISP, right, and this DNS resolver actually acts as a middleman, and it takes the browser's request and then queries other servers to track down the IP. In case it does not have the IP in its own storage, in its own cache, then it will contact the other servers to track it down, right. So your computer connects to DNS resolver, which connects to other DNS servers to track down, to figure out the IP corresponding to a domain name corresponding to a URL that you as through your client device you are trying to access. So first stop is DNS resolver whenever we are trying to access a website. Now second stop is root name server. So root name servers, they represent the top level of the hierarchy, and they do not know the exact IP, but they can look at the extension of the domain name, web extension that is there in the domain name, for example .com, and they can point to point the resolver to the correct top level domain server. So, top level TLD server. So, they can redirect the DNS resolver towards a correct, right, towards a correct TLD server, top level domain server. And so that is the role played by new root name servers. And so if the DNS resolver doesn't have the mapping in its cache, it will contact the root name server, which will then redirect the DNS resolver to the correct top level domain server, right. So then there are few more servers which complete this tracking of IP, and that we will be talking about in the next session. But doing a quick recap of what we talked about in this session, we started with the IPv4 format and dotted decimal notation, 4 numbers, possible address space to the power 30, looked quite big, but then we ran out of IPv4 addresses because of explosion of devices, inefficient allocation. Then firms have to buy IPv4 addresses from other firms which have extra. And what was the better solution? Better short term solution was the NAT, right, network address translation. So, essentially a single public IP address is shared across multiple devices, and that has its own benefits also. Not only the drawback is the slowness, but there are other benefits that we talked about: IP address conservation, network cost efficiency, security and privacy, right. Then long term solution we talked about is the IPv6, and which increases the possible address space to the power 128, which is quite huge, and therefore it resolves that it will resolve eventually when the wide scale adoption happens, it will resolve that problem. So, it is expressed as 8 numbers, each of those numbers will have 2 bytes, and those numbers are actually hexadecimal digits. So, in case of IPv4 those were decimal digits, in case of IPv6 these are hexadecimal digits, right. So, this is how an IPv6 address looks like. Then the transition challenges, the lack of backward compatibility we talked about, and still we are yet to make the transition. And then when you are accessing, coming back to the domain name and the URL thing that we discussed earlier in previous sessions, when you are typing a URL, you are specifying the domain name as part of that, and when you are accessing a particular website, but the machine, the computational node only understand numbers. So, therefore, there has to be translation from domain name to the numerical IP addresses, which are understood by the computational nodes, right. So, the domain name system is needed for that, and we talked about why this mapping, what is the role. So, human computer interaction is there, and human only can remember the names, and just like the case of telephone directory. So, then we talked about DNS resolver, which plays the primary role of conversion, right. So, in case the mapping is not there with the DNS resolver, and then it will contact other servers. One such server would be root name server, which will look at the web extension and redirect the resolver to top level domain server. What happens next? That is something we will discuss in the next session. Thank you.